Hey everyone, welcome. If you're gearing up for your IGCSE exams, you know just how important it is to really get a grip on the forces that shape our world. So today, we're going to break down all the essential science behind natural hazards, and it's all lined up perfectly with what you need to know for your syllabus.
So here's our game plan for this explainer. We're going to travel from the very center of the Earth all the way up into the atmosphere. We'll kick things off with the basics, then dig into the awesome power behind earthquakes, volcanoes, cyclones, floods, and droughts. All right, let's jump right in.
Okay, first things first. We have to start with the most fundamental idea of all. Getting this right is the foundation for absolutely everything else we're going to talk about.
Now, this is a classic exam question, so you're going to want to pay close attention here. Examiners love it when you can clearly explain the difference between these two key terms, so let's make it crystal clear. So, what it all boils down to is this. A hazard is the event itself, the earthquake, the storm, that has the potential to harm people. And that word potential is so important here. And this slide just lays it out perfectly. Look, a massive earthquake happening out in the middle of nowhere, in an empty desert. That's a hazard. It's got the potential to be dangerous, but when that same earthquake happens under a big city where lots of people live, well, that's when it becomes a disaster, because it actually realizes that harm and affects people. All right, next up, we're going deep. Literally, we're going to look beneath the surface at the incredibly powerful forces that create some of the most dramatic hazards out there, earthquakes and volcanoes. Okay, so to understand what's going on, you've got to know the Earth's basic structure. And honestly, the best way to think about it is like a peach. You've got the thin skin, that's the crust, then the fleshy part inside, that's the mantle, and then the stone right in the middle, well, that's the inner and outer core. So deep down, all that heat from the core gets things moving in the mantle. It creates these powerful currents, kind of like a massive super slow-moving conveyor belt. And these currents are constantly shifting those giant puzzle pieces, the tectonic plates, that are just floating on top. And it's right at these edges where the plates meet, what we call plate boundaries. That's where all the action happens. So let's take a look at the three types of boundaries that you absolutely have to know.
First up, we've got the constructive boundary. Now here's a super easy way to remember this. A for away and C for constructive. As the two plates pull away from each other, magma from the mantle rises up to fill the gap, and in the process, it creates or constructs new land.
Okay, next up are destructive boundaries. And yeah, they are just as dramatic as they sound. This is where two plates crash into each other. Usually, the heavier oceanic plate gets forced down underneath the lighter continental plate. That process is called subduction, and it generates an incredible amount of heat and pressure, fueling explosive volcanoes and really powerful earthquakes.
And our third and final type is the conservative boundary. Now, what's interesting here is that no crust is actually being made or destroyed. Instead, the two plates just grind past each other. The problem is, they often get stuck, building up an insane amount of stress. And when that stress is finally released, bam! You get a violent earthquake.
All right, we've been deep inside the Earth, so now let's head way up into the atmosphere. We're going to check out how those massive, swirling storms we call tropical cyclones get their start. When it comes to cyclones, location is everything. You can see on this map they only form in these very specific bands over tropical oceans. But here's the interesting part. They can't actually form right on the equator. Why? Well, there's a key ingredient missing right there, and we're about to find out what it is. So, think of it like a recipe. You absolutely need these three ingredients to cook up one of these massive storms. First, you need really warm ocean water as fuel. Second, that warm water has to be pretty deep to provide enough energy. And third, you need something called the Coriolis effect. That's basically a force created by the Earth's rotation that gets the air to start spinning. And that's the secret ingredient that's missing at the equator. Okay, let's switch gears and talk about our next hazard, flooding. This one's a bit different because it can be caused by natural processes, sure, but also, and this is happening more and more, by human activity. Now, for your exam, it is so important that you can split the causes of flooding into these two buckets, physical or natural causes and human causes. Let's look at a few examples of each. Let's just zoom in on urbanization for a sec, because this is a really big one. Think about it. When we pave over fields and forests with concrete and asphalt, we're creating what we call impermeable surfaces. The rain can't soak into the ground anymore, right? So instead, it rushes across the surface as runoff, and it can quickly overwhelm rivers and drains.
All right, so we've talked about what happens when there's way too much water. Now let's look at the complete opposite problem, drought. This is what happens when there are long-term water shortages, and it can be just as destructive.
And this just goes to show you, a drought isn't simply a dry spell. It's way bigger than that. It's all driven by these huge patterns in our atmosphere. You could have a persistent high-pressure system just sitting over an area, blocking rain for weeks or even months. Or you could have something like El Niño, which can completely change rainfall patterns across whole continents.
Wow, okay, so we have covered a ton of ground, right? From the planet's core all the way up into the sky. So let's pull all of that together into the ultimate revision tool.
Okay, this table right here, this is your golden ticket for revision. It boils everything we've talked about down to the absolute essentials you need to know. For every hazard, you've got the main cause, where it usually happens, and a keyword to remember. Go ahead and pause here, cover up a column, and test yourself. This is your exam cheat sheet.
And that's a wrap on the causes of natural hazards. We've covered the what, the where, and the why for your IGCSE syllabus. And just to leave you with something to think about, which of these hazards do you think is the toughest for scientists to predict?
We're going to go way beyond just the scary headlines to really get a grip on their true impacts, the smart ways we manage them, and something you might not expect, the opportunities that can actually pop up from all that chaos. So let's jump right in. Okay, take a look at this. I mean, this image really hits home, right? It shows you the raw power we're up against. You've got the crazy vortex of a cyclone, the ground literally splitting apart in an earthquake. Our job here is to look past just the destruction and start seeing these as, complex environmental processes. And figuring out how to manage them, it's not just interesting stuff. It's absolutely crucial for your exams. So here's how we're going to break it all down super simple. First, we'll get into the problem, the huge impacts these hazards have. Then we'll look at the solutions, how we actually manage them. And after that, something really interesting, the unexpected opportunities that can pop up. And don't worry, we'll finish with a quick summary to make sure it all sticks for your revision. All right, let's get into our first section. This is all about syllabus point 6.6, the devastating impacts of these hazards. We're going to look at this from 3 different angles, the social, the economic, and the environmental side of things. Okay, first up, the social impacts. And honestly, the human cost is just huge. It goes way beyond the immediate loss of life or injuries. Think about the invisible stuff, right? The long-term trauma. When whole communities are uprooted, you don't just lose a house, you lose your whole world, your neighborhood, schools, your friends. And then what happens? People often end up in crowded shelters, and that's where things can get even worse, with diseases like cholera and typhoid spreading because of poor sanitation. Next, let's talk money. The economic shockwaves. And these can be just as devastating. We're not just talking about busted up buildings and bridges. The real cost ripples out. It's businesses that can't open, trade routes that are cut off, farmland that's completely wiped out, which puts food supplies at risk. And the cost to rebuild, it can be so massive, it can literally stall a country's progress for years. Imagine, all that money that should be going to schools or hospitals now has to go into just getting back to zero. And of course, there's the environmental damage. This is huge. We're talking about entire ecosystems getting completely wrecked. Wildfires can just torch forests, landslides can totally reshape the land, and floods, they can poison the soil and water for a long, long time. And what's the end result of all that? Well, when habitats are destroyed, wildlife suffers, and we lose biodiversity. It leaves these deep, long-lasting scars on the planet. Okay, so we've seen the impacts, and they're pretty grim. The big question now is, what can we actually do about it? And that brings us right to Section 2, Syllabus Point 6.7. This is all about the strategies we use to manage these massive events. So the easiest way to think about managing hazards is like a timeline. It really boils down to 3 key stages. You've got everything we do before it hits. That's all about preparation. Then there's what we do during the crisis, the immediate response. And finally, all the important work that happens after the danger is gone, the recovery. So let's look at that before stage. This is where being prepared is absolutely everything. And you know what? Technology is our best friend here. We've got satellites in space tracking cyclones and super sensitive seismometers on the ground listening for the tiniest shakes. All that data lets us build these incredible hazard maps that tell us, hey, maybe don't build a hospital right here. This info influences everything, from designing smarter buildings, like earthquake-proof ones that are made to sway instead of snap, all the way to simple things like running emergency drills in schools. And then, it happens. the hazard strikes. In that during stage, everything changes. The focus is 100% on safety right now. This is the moment where all that planning we did hopefully pays off. You hear the warning sirens, people start moving along evacuation routes, rescue teams are sent in. The goal here is simple, and it's the only thing that matters: save lives. That means getting people to shelter and giving them the medical help they need, fast. Okay, so once the immediate danger is over, we hit the after stage. But listen, this is where the really long, hard work begins. The road to recovery is, well, it's a marathon, not a sprint. We're talking about the huge job of rebuilding everything: roads, power lines, houses, and getting basic services like water running again. A lot of the time, this needs help from other countries. But the key idea here, and this is so important, isn't just to put things back the way they were. It's to build back better. That means learning from what happened and creating communities that are even stronger and safer for next time.
All right, now for something that might sound a little strange. This covers syllabus point 6.8. We've spent all this time talking about destruction and risk, but what if I told you that these events can actually create opportunities? I know, it sounds weird, but it's true. Let's dig into how that's even possible.
This is a perfect example. A volcano is like two sides of the same coin. On one side, you've got all the terrifying risks: the poison gas, the lava, the sheer destruction. But flip that coin over and you find some amazing opportunities. That volcanic ash that buries everything, it breaks down to become incredibly fertile soil, perfect for farming. The crazy heat deep underground, we can tap that for clean geothermal energy. Even the spectacular, rugged landscapes that are left behind can attract tourists, and that means new jobs. And hey, this isn't just about volcanoes. It works for other hazards too. Think about a flood. Yes, it's destructive, but it can also dump a whole layer of amazing fertile silt all over farmland. That's a natural fertilizer. Floods can also help refill our underground water supplies. Those are called aquifers. Even earthquakes, which are caused by tectonic plates shifting, can push valuable stuff like gold and other minerals closer to the surface where we can actually get to them. Okay, let's pull all of this together. We're at our final section, the revision summary. Pay close attention to this next bit because it's a fantastic tool for your exam prep. It's going to connect all the dots for us, linking the impacts, the management, and the opportunities all in one neat package. So check out this table. Seriously, this is gold for revision. Just follow one of the rows. Let's take volcanoes. You see the impact, which is destruction from lava and ash. Then you see the management strategy, like monitoring with satellites. And that connects right to the opportunity, like fertile soil and tourism. See how it flows? Let's do flooding. The impact is damage and crop loss. The management is building levees. The opportunity is that fertile silt. Thinking about it like this, as a whole connected system, is exactly how you nail this topic in your exam. So as we wrap up, I want to leave you with a big question to chew on. We've seen some pretty cool examples of opportunities coming from hazards, but can we always find a silver lining? Is there always an opportunity to be found in every disaster? Or are there limits to this? It's a tough one. There's no easy answer. But asking those kinds of challenging questions, well, that's what environmental management is all about.